Yes. Hello students, my name is Professor Anurag Deolkar. In this lecture, I am overviewing this subject Control System 2. This is the subject in the 7th semester of Electrical Engineering in SPPU Pune. So we have already gone through the subject Control System 1 in the 6th semester of Electrical Engineering. Okay. So basically the prerequisites for this particular courses are basic concepts of control systems, transfer function, and pole zero clock. Okay. This subject has some course objectives which are aimed to explain the basic digital control system and the concept of sampling and reconstruction. Second, elaborate the concept of state and to be able to represent a system in the state space format. Next, solve the state space equation and familiarize with the STM and its properties. Design a control system using state space techniques, including state feedback control and full order observer. Course outcomes we are expecting upon the successful completion of this course, the students will be able to do following things. First, recognize the importance of digital control system. Second, derive pulse transfer function. Third, analyze digital controllers. Fourth, convert system in state space format. Basically, that is the transfer function to state space format. Fifth, solve state equations. Sixth, design observer for system. You'll see the contents for this particular subject. Unit 1 is titled as Digital Control System, which goes through introduction, configuration of the basic digital control system, data acquisition, data conversion, sampling, reconstruction, few theorems, and importantly, zero order hold and its transfer function. Unit number 2 contains set transform and the pulse transfer function, in which the review and the inverse review of the set transform and inverse transform, difference equations using the set transform method, pulse transfer function, and set transfer function, general procedure for obtaining the pulse transfer function, and ZOH, that is the zero order hold. Third unit is about the stability analysis, which has the points sample data, closed loop systems, characteristics equation, causality and the physical reliability, realizability of discrete data system, realization of the digital controllers, direct digital programming, mapping between the S plane and Z plane, stability analysis of closed loop system in Z plane using test and bilinear transformation. Fourth unit is about the introduction to state space analysis. Introduction to state space analysis consists of the basic definitions about the states, what are the states, the state variables, state vectors, state space, state equations, output equations, the state space representation for the electrical and mechanical systems, as we have seen in the control system on the similar domain. Okay, the conversion of the transfer function to state space model and vice versa. Next unit is the solution of state equations. Concept of diagonalization, eigenvalues, eigenvectors, diagonalization, solution of homogeneous and non-homogeneous state equations, evaluation of STM using the Laplace methods. Last unit, the design of control systems using state space techniques. Okay. It has the points, concepts of controllability and observability. These are very important points, and their respective test condition for the controllability and observability, effect of the pole zero cancellation on the controllability and the observability, duality, pole placement by state variable feedback, and the necessity of an observer. That is the objective of this particular, one of the objectives of this course. Okay, so we'll continue with the first unit hereafter. Okay, so these are the few books that SPPU has recommended. Is the K. Ogata, Benjamin Q, I.J. Nagarath and Gopal, J. Nagarath and Gopal. These are available in our library as well. Okay. So we'll continue in the next lecture with the actual points of the unit 1. Thank you.